Look at page 10 in your journal, and we're going to take a look at horizontal stretches and shrinks as well as vertical. So focusing on the horizontal, we can see that the factor is multiplied inside f of x, and it's also the reciprocal of the number given. So for example, if I have a horizontal stretch or shrink by a factor of, let's say 1/2, my function is going to be f of 2x. So you would plug in 2x to the function, not 1/2 x. And if my factor is 3, then my function would be 1/3 times x. Looking at vertical stretches and shrinks, it makes a little bit more sense because we just take the factor and multiply it on the outside of the function. So if I had a factor of 7, I would just say that y equals 7 times f of x, and let's say f of x was x plus 1. So I would say this is 7 times x plus 1, which would be 7x plus 7. Another example would be if I had something like 3/4 as my a, my factor, and I wanted to multiply that by f of x, I would say 3/4 times f of x, and then make sure you're distributing it to the whole function. So this would be 3/4 x plus 3/4. Now let's take a look at the notes. And in example 3, we're going to do for part A horizontal shrink with a factor of 1/3. So that means my g of x is going to equal f of, remember, flip it, 3x. And now I can just plug in 3x to my original function right here. So that's going to be my answer for part A. In part B, I want a vertical stretch by a factor of 2. So that's just 2 times f of x, which is 2 times x minus 3, the absolute value, minus 5. Make sure here you distribute that 2 in front of the absolute value and to the minus 5. So your final answer will be 2 times x minus 3, and then minus what? 10. And that will be your final answer. If we take a look at example 4, it's combining all of our transformations that we know. So we know g is going to be a vertical shrink by a factor of 0.25, followed by a translation 3 units up. And this is my original f of x. So I know that g of x is going to equal a vertical shrink would mean multiplying the function by 0.25 times f of x, and then a translation 3 units up, so plus 3 would go after that. So if I just plug in my f of x, I'm going to get 0.25x plus 3. For example 4b, we want h to be a horizontal stretch by a factor of 8, followed by a translation 10 units down for my function f here. So I know h of x will equal f of 1/8 x, and then 10 units down would be minus 10. So that's just 1/8 x minus 10. Tomorrow we'll try the monitoring progress, so bring your packets and journals to class.